All right, so if I can just get everyone to listen quickly, I'll talk about what I'm going to do. So I'm going to go through 2 questions from the test, so you're welcome to watch. Maybe you're happy with how you went on these 2 questions, in which case you don't have to. Feel free to go about what you're doing. So that's what I'm going to start with. We're going to go through this one, which is question 8a, and then we'll go through question 9b. So they're the 2 questions I'm going to go through. So you're welcome to watch, or you're welcome to continue with what you're doing. And once we've done that, we'll do a conjecture problem together, where I will get everyone to stop. Okay, so this is a show that question, and what we're required to do is to differentiate it. So that's our first thing. I'm going to smash it all together first. So I have u dash v. Take away u v dash. And that's all on top of v squared. V squared. So when we have a show that question and it's involving square roots and fractions and so forth, what we want to do is represent everything in its correct position with regards to the fraction. And just like when we were doing first principles, I think the best way to deal with this denominator is to just bring that out the front, okay, as a factor of, I'm going to do that in the first step here, I'm going to make it 1 on top of, and the half and the squared will cancel, so we're just going to have 1 on top of 2x plus 1. Alright, so now I've moved that denominator out the front. All I have to deal with now is the numerator, okay? And the first thing I'm going to do is express everything as a root and with its correct location in the fraction. So at the moment, this is just minus 3 root 2x plus 1. And this component is minus, we have 2 take 3x. Now, a couple of people were missing brackets. Make sure you use brackets excessively, because that negative needs to distribute. And then this component is 1 on top of 2 root 2x plus 1. Okay, so this can go to the top. All right. And so that out the front's really helpful, because now we don't have this mountain of fractions to deal with. And so if I want to combine these terms together, I need to make them have the same denominator. So the denominator over here is 2 on top of 2 times root 2x plus 1. So we're going to multiply this whole term by, I'll make some room for it, I'll put that negative there. We're going to multiply it by 2 root 2x plus 1 on top of 2 root 2x plus 1. Okay, so we're multiplying it by 1. We're not changing its value. All right, and we're just multiplying this term. So then let's state what we would have if we did that. 1 on 2x plus 1 multiplied by, at the top here I'm going to have minus 3 root 2x plus 1 multiplied by 2 root 2x plus 1. Okay, and all of that is on top of 2 root 2x plus 1. Take away, and then we have the 2 take 3x, all on top of 2 root 2x plus 1. Okay, so the reason we did that, right, is so that they have the same denominator. Now that they have the same denominator, we can just write it as one denominator. So rather than do it in 3 steps, let's just, because they have the same denominator, we can bring them together. All right, so what we have is this part, take away this part on top of that denominator. And so if you're looking, all right, the denominator that they want us to get to, why do I have an extra 2 out the front? Where did I create that? Here. When I differentiate that, that multiplies by 2. And so the half and the 2 will cancel. So that's not a half, and that 2 is not there. Sorry about that. Alright, so we're just multiplying by root of 2x plus 1. Okay, so we're going to multiply that out and collect like terms at the top. And if you're looking at the bottom, that's what we have at the bottom. That's what it wants us to show. Root 2x plus 1 times 2x plus 1. So we'll just keep it there for now. In here, I have root 2x plus 1 times root 2x plus 1. That just becomes 2x plus 1. Okay, distribute this minus 3 here. This negative needs to distribute, so it becomes positive 3x. And then when we collect like terms at the top, minus 6x plus 3x, that's going to be minus 3x. Minus 3 take 2, that's minus 5. And we're left with at the bottom that times that. Now you must put brackets around it, otherwise it looks like you've got 2x plus the root, but you're multiplying them together. Okay, any questions about that one? All right, let's talk about 9b then. Okay, so we've got the derivative function, and even if you can't get part A, we've got, they give you the derivative anyway. So the derivative function, I'll just make the case. This is the derivative function. 6 cos 3x, cos of x. Okay, take away 3. 6 cos 3x multiplied by cos of x, take 3. Make sure we get brackets in the right spot. U dash v, good. Put another one there. And then we have take away negative, so take away u, so it becomes positive. 2 sine of 3x, sine of x. All on top of v squared. Okay, now we want to know it at x is pi on 3. So I'm going to put pi on 3 where the x is. All right, so what that makes it is 6 cos of 3 pi on 3 multiplied by cos of pi on 3, take away 3, plus 2 sine of 3 pi on 3 sine of pi on 3, all on top of cos of pi on 3, take away 3, squared. Alright, so all I've done there is substitute pi on 3 where the x is into the function we're given. Now, it does simplify a little bit, because if I have 3 pi on 3, the simplest way for me to write that is pi. So I'm just going to go through and fix those ones. That's going to be there and there. And then we're just looking at our unit circle. So I have 6 times cos of pi. Okay, cos of pi, when I look at my unit circle, cos of pi is minus 1. So that part's minus 1. Then I have multiplied by cos of pi on 3, take away 3. Cos of pi on 3, take away 3. So cos of pi on 3 is half, take away 3. Okay, so I'm just breaking it down into its components, right? And then over here, this is going to be beautiful over here because we have sine of pi. So I basically have 2 times sine of pi, if I look at my unit circle, that's 0. So this whole component then is 2 times 0 times root 3. That whole thing is going to 0. Okay, so we can disregard that component of it. And so then we're just left with the denominator, which is cos of pi on 3, take away 3. Cos of pi on 3 is half, take away 3, and it's squared. Okay, so what I'm going to do next is just state what have we got left once we apply that. So we'll have minus 6 times, and at the top, half take away 3, that's minus 2.5, or minus 5 on 2. Okay, that whole thing's going to 0. And at the bottom, we're going to have half take away 3, which is minus 5 on 2, but it is squared. Okay, so that's what that becomes. Now the squared is going to make it positive, so at the top here, minus 6 times minus 5 becomes positive 30 on 2. And at the bottom here, we'll have 25